All right, everybody, we are going to attempt to prove the following thing, that for each positive integer n, the first n odd integers squared added together equal this n times 2n minus 1 times 2n plus 1, all divided by 3. So step one, show that it's true for n equals 1. So we would have, if n equals 1, we would just have 1 squared. That's our entire left-hand side. And we just want to show that that's equal to 1 times 2 times 1 minus 1 times 2 times 1 plus 1, all divided by 3. And so this is, of course, 1 on the left-hand side, and that's 1 times 3 divided by 3, which is equal to 1. So we're good. Step 1 is done. Step 1 is often that easy. You're just plugging in 1 for n, and so you just have this first term, and then you plug in 1 for n on the right-hand side, and you see that it's the same. So step 2, and I always like to break it down into A and B. So A, we are assume 1 squared plus 3 squared plus plus 2k minus 1 squared is equal to k times 2k minus 1 times 2k plus 1 over 3. So really what it just ends up looking like is us replacing n with k, and that's kind of true. We just can't use n because we can't assume that it's true for all values of n, because then you're assuming the thing that you're trying to prove, and that's not true. We're just assuming it's true for some k, for some value of k. It doesn't have to be all of them. It's got to be true at least once. If this is true once, can I then prove that it's true for the next one? So our goal is to prove that this will hold for k plus 1, that this holds for n equals k plus 1. So in other words, we're trying to show that 1 squared plus 3 squared plus plus 2k minus 1 squared plus 2k plus 1 minus 1 squared. So k, we're not ending at k, we're ending at the k plus 1 term, is equal to k plus 1 times 2 k plus 1 minus 1 times 2 parentheses k plus 1 close parentheses plus 1, all divided by 3. Now I think it's worth simplifying the right-hand side just to keep our lives a little bit easier. So this is going to be saying that this is equal to k plus 1, and then that's going to be 2k plus 2 minus 1. We'll simplify this even more in a second. 2k plus 2 plus 1, all divided by 3. Just saying we're trying to show that this is equal to k plus 1 times 2k plus 1 times 2k plus 3, all divided by 3. So we're trying to show that this left-hand side thing over here is equal to that, but we are not assuming that it's true. We are trying to prove that it's true. So to do that, we're going to do the following. So we're going to draw a line, and I think you guys should do this as well on your own. And you should be taking notes with this as though it was regular class and you're writing everything down. Okay, so we have 1 squared plus 3 squared plus plus 2k minus 1 squared plus parentheses 2 parentheses k plus 1 close parentheses minus 1 squared. I know that's really gross. What we can assume, what we have assumed, is that this thing is equal to this thing, because this was our assumption all up here in part A of step 2. So let's write that in. So it's k times 2k minus 1 times 2k plus 1. K times 2k minus 1, 2k plus 1, all over 3. And we are still then adding, this guy is 2k plus 2 minus 1, whole thing squared. I'm going to, at all costs, attempt to avoid foiling things out. Now, I might not succeed, but I'm going to try. So we're going to go from here. We're going to say, all right, this is k times 2k minus 1 times 2k plus 1, all divided by 3, plus 2k plus 1 squared, just doing 2 minus 1 in there. And I'm recognizing that I'm going to need an over 3. So in order to make that happen, we're going to put a 3 up here and a 3 down there. All right, so I'm running out of space on this app, but I think we can kind of make it happen. We're kind of coming up to here. So here we have k times 2k minus 1 times 2k plus 1 plus 3, 2k plus 1 squared, all divided by 3. And we're going to just try to manipulate this, and luckily we know what we're trying to get to. We're trying to get to this whole thing. So if we can make that happen, we'll be happy. Though I'm looking at it and it's feeling unlikely. So let's keep going. So what we're going to do is we can recognize that there's a 2k plus 1 here. There's a 2k plus 1 here, that there are 2 of them. And so let's factor that out. Let's do 2k plus 1. We're going to be left with k times 2k minus 1 plus 3 times 2k plus 1, all divided by 3. And I think this is going to work out just fine. We're just not going to be able to avoid foiling. We're going to have to do it eventually. So we have 2k plus 1 multiplied by 2k squared minus k plus 6k plus 3, all divided by 3. That's a 6 right there. And it's not even foiling, it's actually just distributing that guy to there, and this one to there, and there. So let's recombine some like terms. So I'm moving up to here, and I'm so sorry for the messiness of this. So this is 2k plus 1 multiplied by 2k squared plus 5k plus 3, all over 3. And the hope that I have is that we can factor this second parenthesis. All right, now I recognize the leading term isn't 1, the leading term is 2, so that adds an extra challenge, an extra wrinkle, but you can do it. So here we go. We are going to do 2k plus 1 multiplied by, and we've got to factor this thing. Well, one of the leading terms needs to be 2k. One of the leading terms needs to be k. And we got something with a 1 and a 3, and I think we can do a plus 3 and a plus 1. Now, there is an algorithm for factoring trinomials where the a term is not equal to 1, but I think this is a guess and check where you can do it. And if you look and just check, are these two things multiplied together equal to 2k squared plus 5k plus 3? I think you will find that the answer is indeed yes. So looking at this, we've actually done it, believe it or not. All we have to do is rearrange this, because remember, we're trying to get to here. We're trying to get this thing to look like that, and we did it. The only thing is the 2k plus 3, the 2k plus 1, and the k plus 1 are in the wrong order. We could just rearrange that. This is just equal to k plus 1 multiplied by 2k plus 1 multiplied by 2k plus 3. Of course, still all divided by 3, and we're done. We've actually showed it. We showed that it was equal to this thing that we were trying to get it to equal. I keep getting these lines. I think it's just my hand dragging on it. But we were just trying to get it to equal this guy right here, which was, of course, equivalent to this thing right there. And we did it. We did it. We're just trying to rearrange the stuff. And again, I recognize that there's a lot of factoring in here. There's a lot of algebra in here. So you've got to like be really, really solid with all that stuff. But if you are, then we're done and we're all good. We'll do another one. Of course, I'll do another one. Maybe even two. Okay.